Okay, so here is another order of operations lesson. And in today's lesson, we're going to learn how to continue to learn order of operations that incorporate fractions. Okay, so you remember order of operations. Um, we look for parentheses. Well, I don't see any parentheses here, and there aren't any exponents as well. So the next thing down the line is multiplication or division. I don't see either of those operations as well. And the last thing we have is adding or subtracting. So when we add or subtract, we always want to go left to right. Okay. So what we have is, we'll do this. Okay. So 10 plus 4 is going to be 14. Okay. And now what we want to do here is we want to go left to right, okay, to prevent any problems. It's always recommended that you don't take any odd shortcuts and start adding things that are way beyond to the right. Start from the left, work your way towards the right. You do that every single time. You won't run into any issues. That's my best recommendation. And if you do it otherwise, then the chances of you making an error are going to increase. So, we should be consistent, follow it from left to right, and that way there's no doubt, there's no problem that you're going to get the answer. If you alternate a little bit, it's so easy to write something differently or just make a small error, and then the whole problem will be wrong at the end. So rather than taking that chance, I'm just going to follow it left to right, okay? And in this case, you do 14 minus 3 halves, okay? So when we do that, okay, we're going to write 14 over 1, and we're going to take away 3 halves, okay? So if you use the butterfly method, then that's pretty straightforward. That's going to equal 14 times 2. Remember, we're subtracting, and then we're going to do 3 times 1, okay? Or 1 times 3. Doesn't matter the order of the two numbers. And then we multiply the two denominators, straight across. So that's going to give us 1 times 2. And when you simplify it, this is going to give me 28 minus 3 over 2. 14 times 2 is 28, minus 1 times 3 is 3, and then divided by 1 times 2 is 2. Okay, so 28 minus 3 is 25. Okay, over 2. All right, so we have 25 over 2, take away 9 over 2. And now it just becomes a simple subtraction because the denominators are identical. Can you see that? So that means we can write this as one fraction and then just perform the operation of 25 minus 9. Okay? So 25 minus 9 would be 16. You divide that by 2, and you will get positive 8 for your solution. Okay? So that would be your answer. Now, if you do the two fractions first, okay, this is where you have to be really careful. All right. So if you do that, and if you decide to do these first, then what people often forget is that the minus, they don't realize that the negative really belongs to the 3 over 2, the 3 in the numerator for this particular fraction. Okay, so what this really is since the denominators are the same, it's minus 3 minus 9 which gives me minus 12 over 2, which gives me minus 6. So then you have 14 minus 6 will give you the 8 as well. But I don't suggest you do that if you don't realize that the negative belongs with the 3. Sometimes I see an error where people put positive 3 minus 9 like that, and then that is totally different, and that will give you a different answer. So that's kind of why I like to steer people away and just go left to right, and it just eliminates any guesswork or any doubt. I think it's just better just to go left to right, okay? So, just a little tip there, okay? Just be like really careful. Okay, it's really minus 3 minus 9. Okay? But either way, the answer is going to be 8. All right? So just be careful with something like that. Let's do the next one. Okay, 2. All right. And we have 11 over 3 minus 7 over 3 plus 2 in parentheses divided by 2/5. All right, so everything in the parentheses is going to be dealt with first. And when we read it from left to right, we should do this first. Okay? So if you have 11 over 3 minus 7 over 3, you will know that the denominators are the same, so we just go ahead and do 11 minus 7. Okay? All right. So this is going to give me 4 over 3. Let me write this a little bit neater here. Sometimes the pen slides and... Okay, here we go. So 4 over 3. So we're going to replace that 4 over 3 plus 2 in parentheses divided by 2/5. Notice that we have this to contend with. We want to simplify those into one number. So 4/3 plus 2, I'm going to write that over 1. Okay. The common denominator would be 3 if you did it that way, or you could just do the butterfly method. So that's the first round of multiplication. And then you would just write 4 times 1, and then we're adding these to the multiplication of these two. That would be the second round. All right, so then you have 2 times 3 all over. The third round, which is these two denominators multiplied together, which gives you 3 times 1. So that will be 4 plus 6 over 3. 1 times 4 is 4, plus 2 times 3 is 6. And you simplify that, and you're going to get 10 over 3. Okay, so 10 over 3. So now we have to divide, and we'll have to do these two fractions. Okay, so we can do that over here. All right. So remember, we want to keep change flip. So 10/3. Okay, 10/3. Change the division to multiplication, and then flip the second fraction. And then all we got to do now is, now the good news here, we can cross cancel. 2 goes into 2 once, 2 goes into 10 5 times, and that way it's a little bit reduced. And then we just multiply straight across. Okay, And when we do that, we're doing 5 times 5 now, and then 3 times 1. Okay? So if you can cross cancel, that would be great, right? So the 10 and the 2 are both divisible by 2, and we can do that because not only that they are divisible by 2, but one of the numbers is on top, one of them is at the bottom. All right? And then that allows you to cross cancel, even though they're different fractions, okay? So, did I just erase that by an accident? Yeah, that should be 5. Okay, so 5 times 5 is going to be 25 over 3. And that will be my answer. So you take a look at that and see if that makes sense, okay? All right, so we can go ahead and do another one. All right, so here we have 4 thirds to the second power times 5 times 1. All right. Okay, and what we want to do is, this is going to be 4 thirds. Let me write that a little bit better. Okay, it means 4 thirds times 4 thirds twice. Okay, and you would just multiply top to top, bottom to bottom. 4 times 4 is 16. 3 times 3 is 9. So we can go ahead and replace this with 16 over 9 times 5 times 1. Okay, left to right. We have 16 over 9 times 5 over 1. And then nothing cross cancels, so I'm just going to multiply straight across, just like that. All right? And so when we do that, okay, 16 times 5 is 80 over 9. Okay, and then that times 1 is going to give you 80 over 9. So 80 over 9 times 1 is still going to give me 80 over 9. Okay? And I knew that, and that's why I did 16 over 9 times 5. Okay? Get that out of the way, and then times it by 1, and then you're finished. All right? So that is a good example there. Okay? Let's do another one. 1 minus 1 plus 8 minus 2 fifths. Okay? So we don't have any grouping terms or exponents to worry about, and we don't have any multiplication or division. So we can just go ahead and do this from left to right. Okay? 1 minus 1 is nothing. So, that's kind of like saying 0 plus 8 minus 2 fifths, right? But we know it's 0, so we can just go ahead and continue. 0 plus 8, we know, is going to give me 8 minus 2 fifths. We're going to go left to right, and now we finish this operation. So when we do that over here, we can just write that as 8 over 1, take away 2 fifths. And if we use the butterfly method as my first round of multiplication, then I should get 8 times 5. I'm subtracting, and then I do my second round, which is going to be 2 times 1 all over. That's my second round. My third round is I multiply these two numbers together, and I get 1 times 5. So 8 times 5, again, is 40. Take away 2 times 1 is 2. 1 times 5 is 5. 40 minus 2 is 38 all over 5. So that is my final answer, 38 over 5. Okay? All right. We should do another one here. Okay, so we have 2 divided by 8 times 8 minus 2. All right, so to prevent confusion, stick to the order of operations like I showed you, right? Look for parentheses. There's a set of parentheses that we need to do, and within that set of parentheses, we do what's important or what comes first, right? What has the highest priority? 8 times 8 or 8 minus 2? Well, 8 times 8 should come first, okay? And when you do that, that's going to give you 64 minus 2. And then we can go ahead and clear this now. 64, okay, minus 2 is 62. And be careful with this. This is because what this can be written as, okay, this can be written as a fraction, 2 divided by 62. And what you can do is, remember, the first number is going to be your numerator. And then your second number is going to be your denominator, okay? All right, so it has to be in that order, all right? And the second number, okay, that's referred to as the divisor. And that's the number doing the dividing, all right? So we want to put that in the denominator, 2 over 62. And then if you reduce this, the only number, you notice that 2 and 62 are even numbers, and they're both divisible by 2. So 2 divided by 2 is 1. 62 divided by 2 is 31. So my reduced fraction is 1 over 31. So you just have to be careful on how you interpret 2 divided by 62. Okay? So that would be the answer for that one. Okay? And let's go ahead and do another one. Okay, so 1 plus 2 in parentheses raised to the 8 over 5, 8/5 times 3/4 power. Okay, well, you notice that the parentheses are 1 plus 2, so we could probably go ahead and simplify that as 3, okay, to the 8/5 times 3/4 power, okay? And then now we just have to perform the operation of these two. All right, so we can go ahead and do that over here. 8 over 5 times 3 over 4. So we're going to have to simplify the exponent into one fraction. And the operation that it's telling me to do is it's telling me to take the 8/5 and wants me to multiply by the 3/4. Again, when you do multiplication of fractions, you do not have to find a common denominator, okay? So we just multiply the numbers straight across. But before we do that, we want to look to see if there's a numerator and a denominator that we can reduce or cancel, okay? You notice that the 5 and the 3 are not going to cancel. You know, the 8 and the 5 doesn't reduce, the 3 and the 4 doesn't reduce, right? But the 8 and the 4 does. So when you consider that, you think of the biggest number that can go or divide into 4 and 8 at the same time evenly. Well, the biggest number that you can choose is going to be 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. Okay, so now you're going to multiply these two numbers that are left over, right? 2 times 3. And then you would multiply 5 times 1 instead. Okay? And that's what that is. So when you do that, 2 times 3 is 6. And what is 5 times 1 is 5. All right? Okay. So let me go ahead and just... Okay. So the answer would be 3... 3 to the 6/5 power. But we haven't discussed rational or fractional exponents yet. So normally what we would do is that this would be like another lesson. But generally, when we have a fractional exponent, like for example, x, okay, to 1 over n, then you can write it as n over x. Okay, so, and then the 1 would go here, okay? But I haven't taught that yet, all right? Or another way you could write it is, let's say you had y to the a over b, then the base goes inside the radical, the denominator is the root, and the numerator is the exponent. But we haven't talked about that yet, okay? So generally what this would be translate to is you have 3, and then the denominator is 5, so that is the root. That means you're taking the 5th root, and then that is going to be raised to the 6th power, all right? 3 is going to be raised to the 6th power. So you would have to, take 3, raise it to the 6th power, get an answer, and then take the 5th root. But since we haven't done that, okay, the example that I wanted to write was 8 over 3, not 8 over 5. And that would not give me this fractional exponent, at least to this degree. So the example that I wanted to really go over with you was this one. Okay, was 1 plus 2 over 8 over 3. And in the previous problem, I accidentally wrote 5. I'm not sure why I did that. I couldn't see the number. So I accidentally wrote 5. So I didn't intentionally mean to bring up fractional exponents. So this is the problem that I intended to do. And when you simplify this, we're going to do everything in the parentheses, which would in fact be still 3. And this would still be raised to the 8 over 3rd times 3 to the 4th, 3/4 power. And then we can go ahead and take 8 over 3 times 3 over 4. That is what I wanted to simplify. And as I said, we can still cross-cancel the 4. 4 goes into 4 once, 4 goes into 8 twice. We can even reduce the 3's. 3 goes into 3 once, 3 goes into 3 once. So now we have these two to multiply and these two instead. Okay, so it's so helpful to reduce ahead of time when possible. 2 times 1, remember, we're talking about 2 times 1 over 1 times 1. 2 times 1 is 2. 1 times 1 is 1. 2 divided by 1 is still going to be 2. And now when you replace it, we have 3 to the 2nd power, which is what I intended to do. And that's going to equal 3 times 3. Don't forget, this is the base. Okay? And this is the exponent. So the exponent 2 means we take the base 3 and times itself twice. And when you do that, you're going to get 9. Okay? Just keep in mind that 9 is your official answer. Remember, 3 to the 2nd power does not equal 3 times 2. And then that would be 6. That would be no. Okay, an incorrect answer. Okay? You want to be doing this right here. All right? So, all right, sorry about the previous problem, but this is the problem that I wanted to do. And I hope that this will give you a much better understanding of order of operations and fractions. Okay. I hope that this will give you all the practice that you need, or at least all the information that you need to understand the basic concepts when it comes to fractions, order of operations with fractions. Okay? Remember, if you add or subtract fractions, one way is you either have to find the common denominator, okay, and multiply both sides of the fractions by the appropriate number that gives you the LCD. Okay, again, I'm going to do a separate lesson on that, and if that's too complicated or you forgot how to do that, then do the butterfly method when you add or subtract fractions, and you would only use that if the denominators are different. Okay, if you're adding and subtracting fractions with the same denominator, then you do not need to use the butterfly method. Just go ahead and add and subtract the numerators and write it over that one denominator that's the same, and then reduce fractions any way possible. Okay, if you can't, then that's fine, but we always want to make sure we're reducing our fractions in lowest terms. Do not change fractions into decimals. It's not necessary, because when you work with order of operations, okay, and you get mix of decimals and fractions, you're going to have to either change the decimals to fractions or the fractions to decimals. All right, because you can't add a decimal and a fraction at the same time, or do operations with decimals and fractions simultaneously. It's very messy, and it wouldn't make much sense to do that. So, and that will be another video that we can do later. So, having said all that, I hope this is really helpful to you, and thanks for watching. Appreciate it.